Okay, so the first section we're going to talk about in chapter 6 is polygons. So here we have the definition for a polygon. So the important parts are that it's formed by 3 or more segments. So remember, the segment means a straight side. All right, and that they intersect exactly 2 other sides at the endpoints, meaning they're not going to crisscross or overlap at all. Okay? Each of the endpoints, or the points where the polygon meets, is going to be called the vertex. And of course, we already know the plural of vertex is vertices. So to name a polygon, we can name it by using any of its vertices in consecutive order. So I can call this PQRST. I could call this TSRQP. I can call it QRSTP, as long as I'm going in order. So I couldn't jump from Q to T to S to P to R to name this. I can go either clockwise or counterclockwise in a consecutive order. So let's call this, for the first one, QRSTP. Okay. The vertices are going to, that's the sides. That should be going on the last part. And naming the polygon, QRSTP. Okay, the sides, again, remember, are made up of segments, so we're going to use our notation. So I have side QR, I have side RS, I have side ST, T, P, and PQ. Okay. My vertices are the angles where they meet, so I have angle Q is one vertex, angle R, angle S, angle T, and angle P. Okay, so again, sides are segments, vertices are angles, and then when I name the polygon, I can use any order as long as it's going consecutively. Determining if something's a polygon, again, remember that it has to be closed figure, has to have straight sides, and it can't overlap. So my first one would be a polygon, my second one, my third one, all polygons. However, this fourth one, because of the curved side, would not be a polygon. This one would not be a polygon because it crisscrosses over. And this one would not be a polygon because it is not a closed figure. Okay, so when we talk about polygons, we name them based on the sides. Most of these you probably already know. So you can go ahead and fill in your chart. And we have 2 different types of polygons, convex and concave. So you can see the actual definition right there. The easiest way to remember it is a concave polygon. Looks like as though I was supposed to have a side here, okay, and it caved in. So that's going to be our concave. Okay, the actual definition is that in a convex polygon, if I extend a side, so for instance we have this side, if I extend it in either direction, it never passes through the inside of this polygon. Whereas here, when we took this side and extended it, it cuts right through the interior. The same will be true if I looked at this side. If I extend that, it's going to cut through the inside. So anything where if I extend a side, it cuts through the inside is called a concave polygon. Where it does not is a convex polygon. But again, the easiest way to remember it is it kind of looks like a side of your polygon caved in. Okay, so here, this first one here would be a convex. No matter where I draw a line to extend the side of this polygon, it's never going to pass through the inside. So again, if I look at the side, if I extend the length, it's never going to pass through the inside of the polygon. Whereas here, if I had chose any of these sides, we can see that it's going to pass through the inside, so that would make this a concave polygon. Alright, regular polygon. We learned equilateral, we learned equiangular. Equilateral meaning all the sides are equal. Equiangular meaning all the angles are equal. A regular polygon is where it's both equilateral and equiangular. So all the sides and all of the angles are equal. So identifying if any of these are regular polygons. Here we see we have 4 congruent sides because I have 4 tick marks. However, my angles, I have 1 pair of congruent angles and I have a second pair of congruent angles. But this pair of angles is not congruent to this, and we know that because this one has 1 arc mark and this has 2. So because these angles are not the same, this is not a regular polygon. For number 2, I have my tick marks on each of my sides, which means all 8 sides here, or all 6 sides, sorry, hexagon. Okay, all 6 sides are congruent, and then I also have a single arc mark on each angle, which tells me that each of the angles is also congruent, so this would actually be a regular hexagon. For the last one, again, we have our tick marks on all the sides, showing that these are all congruent. However, we have no marks indicating whether the angles are congruent or not, and if we take a look, we can obviously see an angle like this is an obtuse angle, and this one's acute. So although you always should rely on the arc marks to know that something is definitely congruent or not, we can clearly see that these are not. So this would be no. Okay, and for here, these both actually would be equilateral. They're just not equiangular, which means I can't say that they are regular. Okay. Alright, in your notes, we have, okay, so in your notes we skip around here a little bit. The first thing you have is a diagonal of a polygon is a segment that joins, and it would be 2 non-consecutive vertices. Okay, so the rest of that definition is 2 non-consecutive vertices, and for the example they give you with the hexagon, not a hexagon, a pentagon, okay, example of a diagonal would be a segment that connects from this vertice across there, or from here to here. So 2 non-consecutive. Alright, your interior angle theorem, again, yours is a little bit different here, I didn't realize until I was going through the notes, says that the sum of the interior angles of any polygon is going to be 180 times n minus 2, where n is the number of sides. So we can use that to find the sum of the angles in any polygon. Okay, so again, kind of a little screwed up here. Let's not worry about this for a second. On your paper, you have directions to find the sum of the interior angles in a octagon for number 1. Okay, so we know an octagon has 8 sides. So if I want to find the sum, n minus 2 times 180, okay, would be 8 because it's 8 sides. Okay, and when I go ahead and plug this into my calculator, I get 1,080 degrees. Okay, quadrilateral, you would then do the same thing. The only difference is because a quadrilateral has 4 sides, we're now going to use n equals 4. And we get 360. And again, if you repeat this process for a pentagon with 5 sides, we wind up with 540. Okay. Alright, so this example isn't even in your note packets, but we can do it very quickly anyway. For this example, they want to find x. So in order to find x, the first thing we need to do is figure out how many angles total, or what is the amount of degrees in this figure. So first of all, we see that there's 4 sides. So we just said that a 4-sided figure, when we did the math, have 360 degrees. So there's 360 degrees, and I have all these angles. All I have to do is add them up. So I have 80 plus 70 plus 2x plus x, and that's all going to equal 360. When I simplify and solve, I get that x equals 70. Okay? So once we know that formula, n minus 2 times 180, we can figure out the total degrees of the interior angles of any polygon. And then once you do that, it's the same thing as we did when we did triangles, and now with this quadrilateral, I add up the information I'm given and I set it equal to whatever I know the sum should be, and from there I can solve for my missing angles. Okay? Alright. I know that in your notes you also still have some more information here. So when we're talking about the exterior angle theorem, which is on your very last page, we're talking about the angles. Okay, let's just put a little extra blank slide in here. Okay, so my extra exterior angles are formed by extending the side of my polygon. So if I extend these sides, I wind up with these exterior angles. We did this with triangles already, so now we can do it with anything really. And what the exterior angle theorem says, if I add all these exterior angles together, it's always going to be 360 degrees. So the exterior angle theorem is the sum of the exterior angles of any polygon is equal to 360 degrees. Okay? And that's all that you need for your notes for this section. And that's it.